Applying quadratic equations to rate problems. A rate describes how a certain quantity changes with respect to the change in another quantity, often time. An example of rate is speed, because speed is measured in kilometers per hour. It gives us a measure how fast an object is travelling. When solving rate problems, it is often necessary to add two or more fractions with different denominators. Example 10, express 6 divided by x plus 6 divided by x plus 8 as a single fraction. Now to get it as a single fraction, we will need the denominator to be x plus 8, which means that this first fraction we're going to times by x plus 8. So there it is there, 6 times x plus 8. And the 6 we're going to times by x. So when we expand, we get 6x, 6 8s are 48, plus another 6x, all divided by x plus 8, which means we have 12x plus 48 divided by x plus 8. You don't need to show all these steps, which means we're going to have 12x plus 4 divided by x plus 8. I need to factorise because I might be able to simplify there. For B, it says solve the equation 6 divided by x plus 6 divided by x plus 8 equals to 2. Well, we already know what this is. We've worked it out here in part A. So we can write, I'm not going to have to show all the steps out again, 12x plus 4 divided by x plus 8 equals 2. And now I'm going to just solve this one. So I'm going to get 12x plus 4 or equal to x plus 8. I can divide everything by 2, so this will be save me writing it again, 6, and that 2 will be gone, and now I can expand the bracket, so I get 6x plus 24 or equal x squared plus 8 and x. Bring everything over to the same side, so I get x squared, 8x minus 6x becomes 2x, negative 24 equals 0. Factorise this, x equals 0, 6 and 4, so plus 6 minus 4, therefore x will equal 4 or x equals negative 6. Example 11. Car travels 500 kilometers at a speed, constant speed. So that's the distance that it travelled. If it had travelled at a speed of 10 kilometers per hour less, it would have taken 1 hour more to travel that distance. Find the speed of the car. So we'd better say let x kilometers per hour be car speed, because we don't know the speed of this car. Okay, so we know time, that's what we're talking about, 1 hour, so that's what we've got here. So we know the time is the distance divided by the speed. So we've got 500 divided by x. So there's my speed. Now it said if it had travelled a speed of 10 kilometers less, then, 10 kilometers less, then new speed is x minus 10, isn't it? So new speed equals x minus 10. Then it says it would take them 1 hour more. Now that's the time. So the time would be 1 hour more. So 500 divided by x plus 1. And therefore we can find the speed of the car, because we know that that's the total distance. So we've got x minus 10 times 500 divided by x plus 1 equals 500. So the speed equals distance divided by time, and distance will equal speed times time. So there's our speed and there's our time, and we're multiplying them together. So we're going to work all this out. So when we work this out, I'm just going to quickly do this. I get 500x equals x minus 10, 500 plus x, and I get 500x equals 490x minus 5,000 plus my x squared. I'll put it all on one side, so I get x squared minus 10x minus 5,000 equals 0. And now I've got to solve this. I'll use the quadratic rule. B negative b plus or minus the square root b squared minus 4ac all over 2a. So negative b, so I've got negative 10, that becomes positive 10 plus or minus b squared, so that's 100 minus 4 times 1 times 5,000, all divided by 2, which will give me 5, and in bracket 1 plus or minus the square root of 201. Therefore, the speed is 1 plus the square root of 201, which is approximately 75.887 kilometers per hour. I don't need to worry about the negative because I can't have a negative speed. Example 12 says a tank is filled by 2 pipes. Smaller pipe alone will take 24 minutes longer than the larger pipe alone, and 32 minutes longer than when both pipes are used. How long will each pipe take to fill the tank alone? How long will it take for both pipes used to fill the tank? And this is going to take a while to do, so I've actually copied it onto the next page, and we'll go through it there. It says, let C cubic units be the capacity of the tank, and let x minutes be the time it takes for the larger pipe alone to fill the tank. Average rate of flow for the large pipe is C divided by x cubic units per minute. Since the smaller pipe alone takes x plus 24 minutes to fill the tank, the average rate of flow for the smaller pipe is C divided by x plus 2 x plus 24, cubic units per minute. The average rate of flow when they're put together is both of these combined, so C divided by x plus C divided by 24 cubic units per minute. We express this as a single fraction as we did before. So times this one by x plus 4, this one by the x. We get that, and simplifies down to this. Then the time taken to fill the tank using both pipes, well, we've got C divided by that. And when we work that out, we get that one there. Therefore, the time taken for the smaller pipe alone to fill the tank can be expressed as that same thing there, but another 32 minutes, because it takes 32 minutes longer. Then when we work all this out, and I might need to do this one in class with you, we end up getting all the way down, you can follow that through by yourself, that x is either 24 or negative 8. Of course, we can't have a negative answer. It has to be greater than 0 because we can only have positive minutes, not negative minutes. So x is 24. So it's going to take 24 minutes for the large pipe alone to fill the tank, and 48 minutes for the smaller pipe alone to fill the tank, and together 16 minutes.